Now let's do some basic current problems. All we're doing with these are using the definition of current. I is the change in, the current is the amount of charge that passes any point in a given time. Remember, we measure current in amps, and the charge or the change in charge is always in coulombs, and delta T is in seconds. Now, sometimes we're going to be talking about total charge divided by total time, so don't let this throw you off. Um, so I may say that you have a certain amount of charge pass in a certain time. That's really the same thing. Now, if I'm looking for the total charge and say I'm looking for, I have a certain charge, that density that's going past. So say I have electrons going, then the total charge is going to be the number of, say, electrons times the charge on one electron. Remember, the charge on electron is 1.6 times 10 to the negative 19 coulombs. And there's a negative sign there. Now, the charge on a proton is the exact same, but it's positive. 1.6 times 10 to the negative 19 coulombs. Now, suppose I have a steady current of 2.5 amps. This is my current. I equals 2.5 amps. Flows in a wire for 240 seconds. So my time is 240 seconds. How much charge passes through the circuit? I'm looking for Q. I'm looking for my total Q. So I is Q over T. You can use the deltas, it doesn't matter. So Q is it. So I is 2.5 amps times 240 seconds. If I multiply this out, I get 600 coulombs. Now, this one, we're going to be a little bit more challenging. I have a metal wire that has a current of 80 milliamps. So the current is 80 milliamps. So this is 80 times 10 to the negative 3 amps. How long does it take for 3 times 10 to the 20th electrons? So this is a number of electrons. 3 times 10 to the 20th to pass a given cross-sectional area. Now, we can break this up into two parts. I know I is Q over T, but I need the total charge. So I'm going to go on and solve this because we're looking for time. Okay, it's Q divided by the current. Now I have the current, but I need the total charge. So the total charge is going to be N times the charge on one electron. So it's going to be 3 times 10 to the 20th times the charge on one electron, which is 1.6 times 10 to the negative 19 coulombs. And this, I need a 20 there. Whoops, I always making mistakes, folks. It's 48 coulombs. So the time it's going to take is a total charge, which is 48 coulombs, divided by the current, which is, let's see, 80 times 10 to the negative 3 amps. So you wind up with a time of 600 seconds. Now, on this one, I have a charge that passes through a filament of a certain light bulb. In 5 seconds is 3 coulombs. What's the current? Let's see. This is the time, and this is the charge. So the time is 5 seconds. The total charge is 3 coulombs. So current is charge divided by time. So this is 3, divided by 5, or 0.60 amps. My pen's acting up. How many electrons pass through the filament of the light bulb in a time interval of 1 minute? All right, so my time is 1 minute, and I have a charge, I have a current of 0.6 amps. So my total charge, let's say I want a time of 1 minute, and I want the number of electrons. Now I have the current is 0.6 amps. So let's look at this. I is the total charge divided by the time. Now, the total charge is N times the charge on one electron divided by the time. So I'm looking for the number of electrons. So N is going to be the current times time divided by the charge of one electron. All right, now let's change the time to 60 seconds. Okay, so I have the time, I have the current, and I know the charge on one electron is 1.6 times 10 to the negative 19 coulombs. So the current is 0.6 amps. The time is 60 seconds divided by the charge, which is 1.6 times 10 to the negative 19 coulombs. So I get 2.25 times 10 to the 20th electrons.